Assalamualaikum and hi. Today we want to present about gravimetric analysis determination of zinc oxide in whitening cream using precipitation. Gravimetric analysis is a quantitative analytical technique used to determine the amount of a substance by measuring its mass. In this method, the analyte is converted into a stable compound, usually a precipitate, which is then filtered, dried, and weighed. Because the measurement is based on mass, gravimetric analysis is highly accurate and reliable. It is widely used in laboratories for quality control, environmental testing, pharmaceutical products, and cosmetic analysis. Analytical chemistry plays an important role in the cosmetic industry. It helps ensure that cosmetic products are safe, effective, and of consistent quality. Scientists use analytical techniques to identify and measure the concentration of active ingredients, detect impurities, and verify that products meet regulatory standards. This process helps manufacturers produce reliable products while protecting consumer health. Whitening cream is a skincare product designed to brighten the skin and improve overall skin tone. It helps reduce the appearance of dark spots, pigmentation, and uneven skin color. These creams contain active ingredients such as zinc oxide, niacinamide, vitamin C, or arabutine, which work together to improve the skin's appearance while protecting it from environmental damage. Zinc oxide is one of the most common ingredients used in cosmetic products. Its first function is UV protection. It acts as a physical sunscreen by reflecting and scattering both UVA and UVB rays, helping to prevent sunburn and skin damage. Secondly, zinc oxide supports skin whitening by protecting the skin from UV exposure, which is one of the main causes of pigmentation and dark spots. Also, zinc oxide does not directly bleach the skin. It helps maintain a brighter and more even skin tone over time. Lastly, zinc oxide has anti-inflammatory properties. It helps soothe irritated skin, reduce redness, and promote skin healing. Because of these benefits, zinc oxide is also found in products for sensitive skin and baby skincare. In this experiment, gravimetric analysis is used to determine the amount of zinc oxide present in whitening cream. The zinc is converted into a stable compound that can be separated, dried, and weighed. From the measured mass, the amount of zinc oxide in the sample can be calculated accurately. This method is simple, reliable, and widely used for quality control to ensure that cosmetic products.
There are three objectives in this experiment. First, to determine the zinc oxide content in whitening cream. Second, to quantify zinc oxide through precipitation and mass measurement. Third, to assess the effectiveness of gravimetric analysis in cosmetic quality control.
My name is Nur Aisan Isak. Now, let's look at the theory behind gravimetric analysis. Simply put, this is a mass-based technique. We are measuring the exact weight of a solid product to figure out the concentration of our target analyte, in this case zinc. This relies entirely on the law of definite proportion. Because the final solid has a non-stable chemical formula, we can use simple stoichiometry to back calculate the original content. To get there, we follow a 5-step sequence. We start with dissolution and precipitation, move on to isolation and purification via filtration, and finish with thermolysis, which is heating or calcination before final quantification. This split our chemical reaction into two main stages, the precipitation phase, where the solid form, and the calcination phase, where we heat it to drive off impurities. When the precipitate form, it goes through nucleation and particle growth. As chemists, our goal is to control the relative supersaturation to favor growth over nucleation. Why? Because we want an ideal precipitate. We are looking for something with ultra-low solubility, so we don't lose any sample, large crystalline particle for easy filtration, high purity and a definite composition for accurate weighing, and a non-hygroscopic nature, so you want to absorb moisture from the air. By hitting this metric, we can precisely quantify the zinc content in commercial product, like the cosmetic cream shown on the right.
Next, I will explain the experimental methodology used to determine the amount of zinc oxide in whitening cream using the gravimetric precipitation method. First, let's look at the apparatus used. An analytical balance is used to weigh the sample accurately. A beaker and a glass stirring rod are used to prepare and mix the solution. During filtration, we use a filter funnel and filter paper to separate the precipitate from the solution. The precipitate is then heated in a crucible using a drying oven. Finally, a desiccator is used to cool the crucible before weighing to prevent moisture from affecting the result. The reagents used are the whitening cream sample, dilute hydrochloric acid, oxalic acid solution, and distilled water. Dilute hydrochloric acid is used to dissolve the zinc oxide in the cream. Then, oxalic acid reacts with the zinc ions to form a zinc oxalate precipitate. Lastly, distilled water is used to wash the precipitate and remove any remaining impurities. Let's go through the procedure. First, about 2 grams of the whitening cream is weighed into a beaker. Dilute hydrochloric acid is added and the mixture is heated gently while stirring until the zinc oxide dissolves completely. The solution is then filtered to remove insoluble impurities. Next, oxalic acid solution is added slowly while stirring, causing zinc ion to form a zinc oxalate precipitate. The mixture is left to stand to ensure complete precipitation. The precipitate is then filtered, washed with distilled water, dried, and heated strongly in a crucible to convert zinc oxalate into zinc oxide. Finally, the crucible is cooled in a desiccator and weighed. The heating, cooling, and weighing process is repeated until a constant mass is obtained. This ensures accurate result for determining the amount of zinc oxide in the whitening cream. That's all for experimental methodology. Thank you.
Hi everyone, so for my part, I will break down the precise chemical and mathematical steps behind our gravimetric determination of zinc oxide. As you can see, the analytical process is divided into 2 core chemical phases, dissolution and precipitation. First, the zinc oxide in our sample is completely dissolved using hydrochloric acid, transforming it into soluble zinc chloride and water. Second, we trigger our target precipitation reaction by adding sodium carbonate. This yields our solid precipitate, zinc carbonate, along with sodium chloride as byproduct. To find our final concentration, we follow a simple 3-step mathematical sequence. Step 1, we determine the measured masses. We started with exactly a 1 gram sample of the cosmetic cream by subtracting the mass of our empty filter paper from the final mass of the paper combined with our dried precipitate. We find that our net mass of dried zinc carbonate precipitate is exactly 0.333 grams. Step 2, we calculate moles of the target ingredient using the approximate molar mass of 81 gram per mole for zinc oxide and 125 gram per mole for zinc carbonate. We divide our precipitate mass by its molar mass, which uses formula moles equals to mass per molar mass. Because the stoichiometry between zinc carbonate and zinc oxide is a clean 1:1 ratio, we will get exactly 2.66 times 10 power of -3 moles of zinc oxide in our system. Step 3, we convert the final percentage. We multiply those moles by the molar mass of zinc oxide to find that the absolute mass of zinc oxide in the sample is 0.216 gram. Dividing this by our original 1 gram sample weight and multiplying by 100 gives us our final results, which are 21.6% zinc oxide. Next, I will talk about application in cosmetic industry. We have quality control and quality assurance and regulatory compliance. Let's look at how these intersect across 2 main operational priorities. First, label claim verification. Cosmetic manufacturers are legally and ethically obligated to ensure that what is printed on the bottle accurately matches what is inside. If a product claims to protect skin or provide whitening benefits based on active minerals, precise gravimetric verification proves that the concentration of zinc oxide in the actual product strictly meets those marketed claims. Second, batch-to-batch consistency. Beyond a single test, routine laboratory testing across different production lines ensures that every single batch, tube, or jar of creams maintains identical performance. This ensures that the consumer receives the exact same texture, visual appearance, and UV protection profile every time they buy the product.
Hello everyone, my name is Nuralish Binti Muhammad and I will be presenting the advantages, limitation, and conclusion of our gravimetric analysis for determining zinc oxide in whitening cream. Let's begin with the advantages. One of the key strengths of gravimetric analysis is its high accuracy because the zinc oxide content is determined through direct mass measurement after complete precipitations, producing reliable quantitative results. In addition, this method is cost-effective as it only requires basic laboratory equipment and inexpensive reagents. Another advantage is that no complex instruments calibration is needed, making the procedure straightforward while maintaining dependable results For this reason, gravimetric analysis remains a widely accepted method for routine cosmetic quality control. Despite these advantages, the method also has several limitations. Firstly, it is relatively time-consuming because the analysis involves multiple steps, including precipitation, filtrations, drying, and wicking until a constant mass is obtained. Secondly, gravimetric analysis performed best when the sample contains a sufficiently high concentration of zinc oxide, making it less suitable for trace level analysis. In addition, sample loss during filtrations or drying may affect the final mass and reduce measurement accuracy. Therefore, careful laboratory techniques and proper handling throughout every stage are essential to obtain reliable and reproducible results. To conclude our presentation, our study successfully met the objective of determining the zinc oxide content in whitening cream using gravimetric analysis. Throughout this presentation, we discussed the analytical principle behind the method, the experimental procedure, the calculation and result, its application in cosmetic analysis, and finally its advantages and limitations. Based on our findings, gravimetric analysis proved to be a dependable analytical technique because it provides accurate quantitative results while remaining simple and economical. Despite requiring more time and careful experimental techniques, it continues to play an important role in cosmetic quality control by ensuring that products meet the required safety and quality standards. This concludes our presentations. Thank you for your kind attention.